Section 1.5, Time and Pi. Before we really understand Pi fully, I think we need to understand how we store time internally. So we'll start with that. Then I'd like to describe how we timestamp the data that we get from interfaces. There's some conversion involved in time zone, etc. So we'll get into that. Next, how we handle daylight savings time, and finally, what our support is for sub-second resolution. So the first topic is how we actually store data on the server. And the first point I should make about that is we archive the data using this coordinated universal time. Now, coordinated universal time, which is abbreviated UTC, actually because of the French spelling of that term, coordinated universal time. UTC is what some people refer to as a Greenwich Standard Time, or used to call it Greenwich Standard Time. It's basically a universal time that that doesn't observe time zones. And by storing this as coordinated universal time, whenever we need to retrieve this data back, all we really need to know is how we've stored it in coordinated universal time and what the time zone is in the local server or the local client. And by having those two pieces of information, we can then display the time properly. Now, we actually store it as a 32-bit integer, counting off the number of seconds since January 1st, 1970 in universal coordinated time. Let me show you a little utility that will demonstrate this. I'm going to use a utility called PIdiag, and I'm doing this from within, as you can see here, or if you notice here, this is within the, we're in the pi/adm directory. So this is an administrative tool, just part of the regular suite of tools in Pi. So I'll do a PIdiag-T, and then I'll just type in some date. Let's go with the 17th of August, I don't know, 1991 at 1300. 17th August has actually been converted into a UTC, 682 million seconds since January 1st, 1970. Well, in any event, that's the most efficient way to store it, as a 32-bit integer counting off from that. We're storing that as UTC, though, as you can see. The local time is slightly different, and the local time is arrived at by comparing the UTC time to my local time zone. So it's very important that you get the time zones correctly when you set up your computers. So as a result, one of the things we recommend is, if it's possible, synchronize the Pi server and the interface nodes so that they both have the same timestamp. There's software that you can buy that will sync to a geosynchronous satellite or some kind of a web timer. It's not required, but it's a good recommendation. You'll notice interfaces themselves will make the adjustment by looking at the server time and apply an offset, so that it's not required, but it's a good practice to keep those as closely synced as possible. Now, when it comes time to actually displaying this information, what we're seeing right here, if we switch over to the clients, you'll see that the client, of course, like Process Book, it's not going to show that number of seconds since January 1st, 1970. What it's going to be showing is the converted value back. The converted value is derived by looking at that timestamp, that universal coordinated time timestamp, and applying an offset based on what time zone the client is in or the server is in. And I say that because the client or the server, because that is something that is settable. If you look at your tools and preferences within most of our clients, there is an option here for which set of timestamps you're actually going to see. Is it going to be the server timestamps or the client timestamps? So if the client is in a different time zone, that's not a problem. You can display either the time of the server or the time of the client.